Okay, good evening. This is Professor David J. De Los Reyes. It's February 1, 2023. My topic for tonight will be, we go a little bit far from calculus. My topic for tonight will be a little bit discussion on trigonometry. Okay, let's proceed, guys. I think these are needed if you are taking something like the SAT exam. Okay, let's proceed. The topic is trigonometry. We are given sine of 30 degrees is equal to 1/2. Sine of 45 degrees is equal to 1 over square root of 2. 30 degrees and 45 degrees are actually spatial angles. So, as a mathematician or as an engineer, okay, we know the values of this by heart. So if you say sine of 30 degrees, we know immediately that it is 1/2. And sine of 45 degrees is 1 over square root of 2. Or actually, in terms of decimal, it's 0.707. The problem for tonight is, the requirement is find sine of 15 degrees, no calculator use. Don't use any calculator, and the problem is asking for the sine of 15 degrees. Given sine of 30 degrees equal to 1/2, and sine of 45 degrees is equal to 1 over square root of 2. Okay, let's try to bring out the solution. We'll check my camera first. To bring out the solution of this, assuming you are on the board exam, it's not the SAT exam, because the SAT exam, I think it's just something like a selection type. But in the board exams, you must have to bring out the solution, okay? Mathematically, it should be something like this. So our orientation for tonight is actually, it seems we are on the board exam. We are not on the SAT exam. But if you are in the so-called SAT exam, the solution will still be the same, but you keep rushing. That's why sometimes the emphasis of others is actually on the speed. But for me, the emphasis is actually on the concept. Okay, let's try to bring out the solution. Since we are given sine of 30 degrees is equal to 1/2, we draw a right triangle. This angle here is 30 degrees. Considering this 30 here, this should be opposite, and this is hypotenuse. So if the sine of 30 degrees is 1/2, this should be 1, and this is 2. And the adjacent side, considering this 30 degrees, should be the square of this, minus the square of this, then take the square root. So actually, the adjacent side, considering this 30 degrees, is actually square root 3. As simple as that one. This is a solution board exam style. Okay? Let's try to bring out sine of 45 degrees. We draw again a 45 degree triangle. So if the sine of 45 degrees, by definition, sine is actually opposite over hypotenuse, right? So considering this 45 degrees, this should be the opposite side, and this is the hypotenuse. So if the sine of 45 degrees is 1 over square root of 2, this is 1, this should be square root of 2. The adjacent side, considering this 45 degrees, should be the square of this minus the square of 1. The square of the square root of 2 is actually 2. And the square of 1 is just 1. So 2 minus 1 is actually 1. So the resulting value of y, the adjacent side, considering this 45 degrees, it should be plus or minus 1. We disregard the negative signs, so y now will be 1. So this side here will be 1. So for a 45 degrees, this is 1 and this is 1. And the hypotenuse is actually square root of 2. And from this, we could now formulate the formula on how to take the value of sine of 15 degrees without using calculator. You might use longhand in the so-called multiplication and division, but in the calculation of the sine of 15 degrees, no calculator. Okay? So I will place it here. Sine of 15 degrees will be equal to the sine of the quantity, the difference 45 minus 30. Okay? Because 45 degrees minus 30 degrees is actually 50 degrees. So if we try to look for the value of sine of 15 degrees, it will be equivalent to the sine of the difference of 45 degrees minus 30 degrees. And this actually emanates from the so-called double angle. From one of the laws of sine of the difference under trigonometry, that is, the sine of the quantity a minus b is actually sine of a cosine of b. If this is minus, this should be minus cosine of a sine of b. So it seems a is actually 45 degrees and b is actually 15 degrees. Is it correct? Oh, 30. B is 30 degrees. Okay? Because 45 minus 30 will be 15. So if we now try to follow this one here, it will be sine of 45 degrees, cosine of 30, minus cosine of 45 degrees, sine of 30. Why did I place the value of the triangles? Because we needed the values. We needed the value of sine of 45, we need the cosine of 30, we need the cosine of 45, and we need the sine of 30. We are now given this side and this side, so actually we could compute for the cosine value. Substituting values now, sine of 45 degrees is actually 1 over square root of 2. Okay? Cosine of 30, the cosine of 30 will be this side here over this. It is square root of 3 over 2. Okay? Cosine of 30 will be this side here over 2. Over the hypotenuse is square root of 3 over 2. So this is actually square root of 3 over 2. Minus cosine of 45 degrees. Cosine of 45 degrees, we have computed this side already. Cosine of 45 will be the adjacent side, considering this 45 over the hypotenuse. And that is actually 1 over square root of 2 times the sine of 30 degrees. Originally, we are given the sine of 30 degrees, it is 1/2. But actually, we could take the value by using the partial triangle, that is actually sine of 30 degrees, it is actually equal to 1/2. Okay? So, simplifying this one, this is now pure algebra. Okay? We could actually factor out, there is a common factor on the first term and second term as actually 1 over 2 the square root of 2. What remains on the first one will be square root of 3. On the second part, it will be minus 1. Okay? This is now 1 over 2 over the square root of 2. Then try to radicalize. We will multiply square root of 2 over square root of 2 to eliminate the square root of 2 underneath. Times. The square root of 3 is actually 1.732. If you are a mathematician or an engineer, it's a must that you memorize the square root of 3. Square root of 3 is actually 1.732 minus 1. And simplifying this one, what will now come out? 1 times the square root of 2 is the square root of 2, and the square root of 2 is 1.414. Okay? Square root of 2 times square root of 2 is actually 2. So 2 times 2 will be 4. So there is an over 4 underneath. Times 1.732 minus 1 will be 0.732. And if we try to perform the multiplication, then divide this, what will come out for the sine of 15 degrees will be 0.2588. Actually, we could check the validity of our answer by displaying 15 degrees over here, 15 degrees, then take the sine value. The value is 0.2588. So it means our answer, sine of 15 degrees, without using calculator, it is 0.2588. I just present the calculator solution as a check. So you believe that our solution or our answer is correct. Oh, that's it, guys. Okay. This is the way how we teach trigonometry for it to be understood thoroughly, you know, because in the short video, if you can understand the video in 15 seconds, you're gone. But in here, I want to present a problem under trigonometry using the so-called long form video. Okay, so for those people who needed trigonometry, you needed this one, guys. It's what's the importance of this? The importance of this is that you are familiar with the sine, the right triangles, and in the computation of the sine function, cosine function, and tangent function. That's why the trigonometric functions are actually the foundation of trigonometry. Plus, on the second thought, it's the importance of the expansion of sine of the difference of two angles. That is the sine of the first angle, cosine of the second angle, minus the cosine of the first angle times the sine of second angle. So actually, the emphasis here is the importance of the definition of sine, cosine, tangent, and the concept on the expansion of the sine value of the difference of two angles. Okay, so for those students who needed trigonometry, this is for you guys. If you like it, please click like. Okay, if you want to subscribe to my channel, this is just a part of the mathematics under my channel. Okay, please click subscribe. My channel is at youtube.com/@ProfDavidJ. And if you want to share it, please click share. I think this is more good, what you call this, explanation than the short videos. This is a long form video of trigonometry. Good evening, Los Angeles.